Hey guys, welcome back to Coding Kaiju. Today we're gonna learn how to make a game in Godot. So our game is gonna be a 2D arcade game. As you can see, our ship's gonna be shooting up asteroids and possibly even enemies later on. It's gonna be complete with sound effects, music, and menus. Alright, let's get started. First thing we're going to do is open up Godot. Let's create a new project, and I'm going to name mine Space Asteroid Arcade Shooter. And I'm going to save mine right here on the desktop. So let's create a folder. And for this tutorial, I'm going to choose OpenGL ES 3.0. Go ahead and click Create and Edit. And this is Godot. By default, it shows us the 3D viewport, but we're making a 2D game, so let's go ahead and click on 2D scene, and it'll automatically switch to the 2D viewport. All right, first thing we're gonna do is rename this node to game. Control S to save, and it's gonna ask us where we want to save our game scene, and here is fine. Before we go any further, we need to import our assets. So go over here to the file system window, and on the root directory, the res folder, right click on it and click open in file manager. And it'll automatically open up where our game is saved. Go ahead and minimize Godot. All right, now open up your browser and go to my website, codingkaiju.com. Link is in the description. Scroll down here and click on this button, download game assets. It'll download and then you can extract it somewhere. I'll just put mine on the desktop. We don't need that anymore. So I have my zipped file here. Let's just extract it. Open it up, and here we have the assets folder. Inside we have our audio for our game, the fonts, the images, and an icon. So let's do that first. Take the icon from the assets folder and drag it over to our Godot project. We're going to replace the default icon. Go back here, and I want to drag the entire assets folder into our Godot project. So now when we open up Godot again, it'll import the assets. Okay, there's one more preparation I like to do before I get started on a new game. Go to Project Settings, scroll down here to the Display section, and click on Window. We're going to define our game's default resolution. So here you can set the width and height of your game in pixels, and you can also set a different test width and height. For this game, we're going to make it 1280 by 720. I think that's a good resolution to use if you intend your game to be played on a laptop, for example. So that's what we're going to do. And then after that, we want to scroll down here to the stretch settings. And we're going to set our stretch mode to viewport and our aspect to keep. And what this is going to do is when the user resizes their window, it's going to keep the aspect ratio of our game so that users with larger monitors can't see more of the game screen. Go ahead and close that and Control S to save. Okay, let's create our first object. First thing we're going to do is create an asteroid. Go up here to this corner and you can click this little plus sign to add a new node. You can also use the keyboard shortcut Control A. When you click on that, these are all the built-in nodes in Godot. You can expand these to see more. And for our asteroid, we're going to use a rigid body 2D. Go ahead and click on that and you can see the description. A body that is controlled by the 2D physics engine. So that's what we want for our asteroid. We want our asteroid to move naturally and collide with other physics objects. So go ahead and click create. And you'll see this little warning icon pop up. This node has no shape, so it can't collide or interact with other objects. Consider adding a collision shape 2D. Basically, it's saying we need to define a shape for this physics object. Before we define the shape, though, we have to know what our object looks like, and that's going to be determined by the sprite. So you can either open up these subnodes, or you can just type in up here to the node you want to use. Quick note, notice the color of these nodes. So this sprite has a little blue icon next to it, and this one down here says Sprite 3D, and it has a little pink or salmon colored icon. So this is for 3D objects, and some of them are labeled as 3D, and the ones up here are blue, and then some of them are labeled as 2D. Make sure we're using 2D nodes because our game is going to be in 2D. Go ahead and click create. And now we have to define the texture property. So over here is the inspector window. This is going to tell us all the properties of our currently selected node we have over here. So as you can see right now, our texture property is empty. Go ahead and click that little drop down and click load. And let's open up our assets folder, images, and asteroids. So these are all the asteroids we can use in our project. You'll notice some of these smaller images are really blurry. That's due to how Godot imports them. That's due to how Godot imports the PNG files. It applies a blurring filter. We can actually change that. If you're making a pixel art game, for example, you would want to change that so it didn't blur it. So I'm going to show you how to do that in a bit. For this tutorial, I'm just going to choose meteor gray underscore big one. Go ahead and open that, and then you can see our asteroid right here. Okay, let's re-import those asteroids. So open up the assets folder, go to images down here in the file system window, and asteroids. Left click the top one, scroll down, hold shift, and then left click the bottom one, and it'll select everything in between as well. So now next to the scene tab up here is the import tab. Go ahead and click on that. And now we can change all the settings of how Godot imports these images. But the quickest way to do what we want is to click on preset, and we're going to import these as 2D pixel. That way Godot won't apply that filter we saw before. It'll just present the images as is. Don't forget to actually press the re-import button. I've done that several times before. You click on that, it'll re-import all the assets. Okay, now let's add a collision shape to our rigid body. Collision shape. Again, make sure you're choosing the 2D one. This is the 3D one up here. We don't want that, we want the 2D one. Go ahead and click create. We actually made a little mistake up here. We added a collision shape to our sprite instead of to our rigid body. But that's an easy fix. Just click and drag the collision shape over the rigid body, and now it will be a direct child of that. And as you can see, the little warning icon went away. But now collision shape 2D has a warning icon. Let's read that one. A shape must be provided for collision shape 2D to function. All right, well, that's an easy fix. Go ahead and select collision shape 2D. And as you can see in the inspector window, the shape property is empty. So click the drop down arrow, and now we have to define a shape. Okay, so we could, let me zoom in over here. By the way, you can use the scroll wheel to zoom in and out, and if you press the scroll wheel down, and then you can hold and drag that to move around the window. Okay, so we could make our collision shape fit the sprite exactly with all these corners and edges. But for this tutorial, we just want an approximation because we're actually going to be using different sprites for different asteroids. So we just want a general collision shape that'll fit most of the sprites. So we're gonna actually use a new circle shape 2D. And then I don't know if you can see it, but a tiny little blue circle appeared. So let's make that bigger. The best way to do that is by going up here, back to the shape property. So instead of clicking the drop down arrow, we're gonna click on circle shape 2D instead, and that will expand its properties. So the default radius is 10, we're gonna change that to 42. So as you can see, the shape lines up really nicely on these edges, but there's the corners overlap a little, and then we have this gap right here. Don't worry though, like I said, we're going to be using multiple sprites, and we just need an approximate shape that will fit most of them. Plus, once everything's in motion, you won't really notice these small imperfections. Okay. Now let's save our asteroid as its own scene. So to do that, we're going to right click on rigid body 2D, and we're going to actually rename that to Asteroid. Then right click on the asteroid node, and we're going to click save branch as scene. This will save the asteroid node and all its children as a separate scene that we can reuse. So to keep our project organized, we're actually going to create a new folder for our asteroid, and we're going to put it in the objects folder and save it there. And now our asteroid is saved as its own scene. So if we go back down here to the file system window, collapse that, open up the objects folder, we can see there's our asteroid scene. You can either double click on that, and that will open up the asteroid scene. Double click on game to reopen it. And you can also click on this little movie clapper icon, and that will also open up the asteroid scene. So make sure if you're ever editing a scene that you have that scene open. If you were to make edits to this asteroid node from here, you would only edit this exact instance of the asteroid. You wouldn't be editing the asteroid scene itself, which would affect every asteroid in the game. All right, let's open up the game scene again. Double click to open it. You'll know it's open because you have that root node that's called game. And we're actually ready to run our project. So go ahead and go up here to the play button. You can also press the F5 key. And it's going to want us to select a main scene. Go ahead and select the game scene we made. And Godot will compile our project and run it when it's done. And notice our asteroid right here on the edge of the screen, and it falls down. All right, let's move our asteroid to the center. Again, make sure you have the game scene open, not the asteroid scene for this. And go ahead and move that asteroid to a more central area. I don't know if you can see it, but there's these faint blue lines here. That defines our game window. So that's how I know I moved it to the middle right here, is because it's within this bounding box that defines the game, that is defined by our game window size that we set earlier. I'm going to put it up here in the middle towards the top. Save that. Play it. And there's our asteroid. Starts right there in the middle and falls off. Okay, now we're ready to make our player. You'll notice the process will be pretty much the same. So the first thing we're going to do is add our physics node. So go ahead and open up node 2D, open up collision object, physics body, and our player is going to be of type kinematic body 2D. So a kinematic body 2D is appropriate for physics objects that will be controlled by code. So that could be either controlled by AI code or by player input code. In this case, our player character is going to be controlled by player input code. That's why we're choosing kinematic body 2D. Really quick though, I wanted to talk about static body 2D. Static body 2D is a physics object that is meant to never move. So that'll be appropriate for things like walls and floors. But our player character is going to be kinematic body 2D. So select that and click create. And we get another warning. This node has no shape. It's the same thing. So before we define the shape, we have to go ahead and add a sprite. Over here to the inspector window, the texture needs to be defined. Go ahead and click the drop down and let's load an image for our player. So go ahead, open up that ships folder, and these are all the ships we can use. You can choose whichever one you want. For this tutorial though, I'm going to choose one of the player ship 3s because they have a very simple triangle shape. I want to choose the green one. All right, now let's add a collision shape to that. So make sure you select the kinematic body 2D first, because we're going to add our collision shape to that. Collision shape 2D. Go ahead and create, and let's define its shape over here in the inspector window. Click the drop down arrow, and you'll notice there isn't actually a triangle option. So we're actually going to have to define our own shape. So to do that, we can add a new convex polygon shape 2D. And if you zoom in here, you notice a little tiny triangle appeared. That's the default convex polygon shape. So go ahead and click on the text convex polygon shape, and you can open it up and see its properties. You can see one of the properties here are points, so we can define the points of the shape. So we open that up. Right now it has 3 points because it's a triangle. You can add more points to create a more complex shape. So now we have to define the coordinates of the shape. So for this one, I'm going to set the first point as 0 on the x, and then negative 32, 40, 28, negative 40, and 28. As you can see, the shape doesn't perfectly line up with our sprite. If you want to, you can spend more time getting it perfectly right, but I think that's good enough for our purposes here. And again, just like before, let's save our player as its own scene. So the first thing I'm going to do, select the kinematic body 2D, right click, and rename that to player. Then right click that player node, save branch as scene. And we're actually going to save our player in a different folder. So click this little arrow to go up a directory. And we're going to create a new directory. I'm going to call this one characters. And this is where we're going to save the player scene. And you see a new folder appeared, and this is where our player scene is. Okay, make sure you have the game scene open. Let's zoom out. And let's move our player right under our asteroid right here. Control S to save, and let's run our project. And there we go. Our asteroid falls and bumps and hits our player's ship. All right, that's pretty good so far. I think we're ready to start coding. So the first thing we're going to do is we're going to add movement to our player ship. I'm going to do that through code. So go ahead and open up the player scene. Again, you can either go over here to the file system window and double click on player scene, or you can go over here to the scene tree and click that little movie clapper icon, and that'll open up player scene. So make sure you're doing this to the root node, the player node. Right click and let's attach a script. You can also have it selected, and you can click this little button to attach a script as well. All right, and it's going to open up this little attach node script dialog. The language we're going to be using is GDScript. Godot also supports C# and C++, but unless you have a really good reason to be using those other languages, you should be using GDScript, especially in the prototyping phase. All right, it automatically inherits whatever node type we're attaching the script to, so that's good. And for this tutorial, I'm going to use the empty template. And then we're always just going to use the default path it saves it in. Go ahead and click Create. And Godot automatically opens up the script window. If you want to go back to the 2D viewport, just go ahead and click on 2D up here. All right, let's quickly explain what's going on here with the script window. So this right here is all the files you have open. So right now we only have one file so far. So player.gd, GD is the file extension for GDScript. This is where all the functions we define are going to appear. You can quickly navigate your file. We don't have any functions defined right now, so it's blank. And then this is where we actually type our code. All right, up here we have a quick and easy link to open up the Godot documentation in our web browser. And we can also click Search Help. Now this is all the nodes, the built-in nodes in Godot, and we can easily look for one. So we're using a kinematic body 2D for our player. And we can actually open up the documentation right here in Godot. And we can read all its methods, all its properties. This is really useful. I use this all the time. All right, go back to the player.gd. Okay, since we're using a kinematic body 2D for our player, that is a physics body. We want to handle movement during the physics step. So there's two main game loops in Godot. There's the default, there's the normal function underscore process. And this process function will run every single frame of your game. What this is different from the underscore physics process. So with the physics process, even if your frame rate is higher, it'll still continue running at a constant rate. I think the default in Godot is 60 times per second. So as long as you're getting at least 60 frames per second, that's how often the physics process function will be called. And that's just to keep the physics simulation smooth. So because we're manipulating a physics object, we want to have our movement code here in the physics process. So the first thing we're going to do is define a variable. Var velocity, and we're gonna say, I'm gonna say that is a vector2. So what's a vector2? An easy way to check is to right click on it and go over here to lookup symbol, and it'll open up that in Godot documentation. So a vector used for 2D math. So it only has two properties, a float x and a float y. So basically a vector2 is a pair of floats, two numbers. So our velocity variable will define which direction our player is moving and the speed at which it's moving. So now let's check for user input. So we're going to say if input is action pressed. So when you're typing code, Godot will automatically suggest things you may be wanting to type. And if you want to select one of them, you can use the arrow keys to go to one. And once it's highlighted, you can press tab to finish it. Godot comes with some input bindings already set. And we're actually going to use one of them, the UI left one. So that is automatically bound to the left arrow key on your keyboard. And we're gonna say the x value of velocity, that's the x-axis, the left and right axis, is equal to negative 600. Then we're gonna say if the input is action pressed UI right, don't forget that colon at the end of your if statement, then we're gonna set the x value of velocity of our velocity to positive 600. So we're reusing the same number, so it's actually better if we store this in a variable. And so we're gonna go up here outside of the function, and we're actually gonna store this in a constant. So a constant is just like a variable, except its value never changes. And usually constants, the naming convention for constants are all capital letters. So we're gonna call this one speed. So we're gonna say this is the speed at which our player moves. So now that we have speed defined, we're gonna go ahead and copy that. And now we can say negative speed and then positive speed. And now we can do the same thing for up and down. So if the input is the up arrow key, then we set the y value, which is the y-axis, to, again, negative speed. And you'll notice that up is actually a negative value. That's just one of the quirks in Godot. And if they click down, if input is action pressed UI down, then the y value of velocity is positive speed. Now to actually make our player move, our kinematic body 2D move, we're going to use the move and collide function. And as its argument, we're going to pass the velocity multiplied by the delta. So what is delta? So you'll notice delta is up here. It's one of the parameters automatically passed into the physics process. So delta is a float, and it contains how much time has passed since the last time the physics process was called. So if a player's computer is having some trouble running your game and we're getting some choppy frame rates, by using the delta here in this calculation, we're going to create a smoother experience from the player's perspective, even if they're getting some lower frame rates. Okay, so now that our input is coded, let's try running our project. And now we can move around. All right. As you'll notice there, our player can move off the screen and we can actually get lost. So how can we fix that? Well, we can either have the camera follow the player around, and that would make sense in certain types of games, but in this game, our camera is actually going to stay still. So what we're going to do to solve this is we're actually going to implement screen wraparound, so that when our player goes off the screen, they come back on the other side. So to implement wraparound, we're actually going to create a wraparound node. Now, fair warning, I didn't write this code. A developer by the name of Speedy actually posted this to his GitHub. So you can go there if you want to see a demo of how it works. I'll link this in the description. Okay, so to add wraparound, make sure to select the root node, the player node. And we're going to add a node of type node. make sure you're choosing this plain white node instead of node 2D. All right, we're gonna rename that to wraparound. And we're gonna save that as its own scene. Save branch as scene. And we're gonna create a new folder for this one. And I'm gonna call this folder common. Basically, this common folder will hold any nodes we make in the project that will be used by multiple scenes. So go ahead and save that. And open up the wraparound scene. And now let's attach a script. Go ahead and create. Okay, so to get the code for our wraparound node, we're actually going to go back to my website. And I'm going to link directly to the section you need, but in case that doesn't work for you for some reason, you can go here to this table of contents and jump to the screen wraparound section. And this is the code we need. So go ahead and copy all that. Go down and hold Shift and click. Control C to copy. And then highlight all that. Control V to paste. So again, like I said before, I didn't write this code, but it's very well commented. Each function is labeled to show you what it does. I did, however, create this function, recalculate wrap area. And then we're also going to add every wraparound node to this group called wraparound. This is going to be an easy way for us to signal any wraparound nodes that if the game window has changed sizes, that we want it to recalculate, you know, when it should wrap. Okay, now let's add wraparound to our asteroid scene. So let's open that up and select the root node. And instead of clicking plus, which would add a built-in Godot node, we're going to click on this link icon. And from there, we can select any of the nodes that we made in this project. So we're going to select the wraparound node. And there we go. It was easy as that. So if we run our project now, the wraparound will work. You can go ahead and try it. And because of the way we set up our project settings, that our viewport gets stretched, we won't have any problem with resizing issues. However, just very quickly, I want to go over how to make sure that the wraparound nodes get updated if you are making a game that resizes the window. So we're just going to go over this really quick. Just open up the game scene, and we're going to attach a script to it. And you'll find this code on the website again under this optional wraparound improvement section right here at the bottom. So you can go ahead and highlight it, Control C to copy, go back here, make sure to get all that, and Control V to paste. And basically what this is going to do is when our game node is created, it's going to connect itself to the resized signal that happens in Godot's hidden default viewport node. And then whenever that resized signal is emitted, basically whenever the player changes the size of their game window, it's going to call the function call wraparound. And we define that here. Basically, we're going to call the group wraparound. Remember, we added every wraparound node in our game to that. And that node's ready function. And we'll call the function recalculate wrap area. Again, our game doesn't need this because of the project settings we set, where we set the stretch mode to keep its aspect ratio and to stretch the viewport. But if you're making a game with different settings, this would be very helpful, as it would, anytime the player changed their game window size, the wraparound would still work. Okay, and of course now when we run our project, wraparound works. All right, we're going to stop there. If you made it this far, be sure to like the video. Be sure to subscribe so you get notified when part 2 comes out. Thanks for watching.